Hello and welcome to Calculus Lesson 5. Today we have some exciting things with word problems. So you may want to have your book open during this lesson or at least be looking at it so you can follow along with the examples in case you get lost. Example 5.1 says Boyle's law says that if the temperature of a quantity of an ideal gas is unchanged, then the product of the pressure and volume equals a constant K. Now, from that sentence, the product of pressure and volume equals a constant K. That gives me enough information to be able to write an equation from it. So, what equation would we write? Product means times, pressure and volume means equals. Okay, from there, so I'm just writing out my word problem. When there are, so now they're going to give us some information. We're going to plug that in and see what happens. So when there are 100 or 1,000 meters cubed, when we see meters cubed, we think volume of a particular ideal gas. The pressure is 5. So they give you enough information to solve for K. K is 5,000. Now I'm going to plug that in and redo my equation because I assume they're going to ask me to solve for something. Let's see. What would the pressure be? So I know I need pressure if the volume was 200. So from there, all I do is plug in the volume, divide out. These are your favorite word problems of old. 50 divided by 2 is 25. These cancel. Pressure is 25. And we take the units from before, which were newtons per meter squared. So read the word problem, make your equation, and then solve. Example 5.2. Let's do it. Woo! All right. Dagny and Lael. Oh, those are cool names. If you're having kids in 30 years, and you have some questions about names for your kids, Dagny and Lael found that the cost varied directly with the number who worked. So how would I write direct variation? Well, just as a recap, direct, we write A equals K times B. And indirect, A is K over B. As B goes up, A goes up. As B goes up, A goes down. It's like reading your Bible, right? As you spend more time with the Lord, in the Word, in prayer, your walk with Christ improves. As you spend time sinning, hopefully you don't spend time sinning, but that reduces or it moves you further away from the Lord. So they say that the cost varied directly with the number who worked or directly with the number of workers, but inversely with the Sabercat index. That's cool. So my equation would be C equals K, W over S. K is a constant. We'll solve for that in the first step, just like we did here. So they're going to give us information, enough information to do that. So the cost was 400 when 5 people worked and the index was 8. So can I solve for K? Absolutely. It looks like 160. Now what I'm going to do is I'm going to redo this. Wow, I messed that up. Let's try that again. 8 times 4, 32. So we have 3,200 divided by 5. That looks like 640. That's better. I'm going to take my K and I'm going to plug it back in to my original equation. Now they're going to give more information. It says, what was the cost? So I'm solving for cost when 13 people worked, and the Sabercat index was 2. I can cancel those. 320 times 13 is 4,160. Make sure you include units, and you are done. All right, we got a couple more, it looks like. At least 2. Ooh, these are really fun. All right, this time the cost varied linearly. So how do we do linear variation? Again, this should be a review from pre-calculus and even algebra 2. The new content will come in one more example problem, so be ready. So linear variation should look like the equation of a line, which is mx plus b. So cost equals m times, what is it vary linearly with? Varies linearly with the number of workers. So mn plus b. Cost varied linearly with the number of workers. This should look like the equation of a line. Now, are we going to be surprised that they give us enough information to solve for m and b? Of course not. When there were 10 workers, the cost was 70. When there were 20 workers, the cost was 120. Can I solve for m and b using these two equations? Just like I solved for k as my first step over here, I'm going to solve for m and b here. If I subtract the first one from the second one, I always draw the arrow so I know which one I'm subtracting. b minus b is 0, 20 minus 10 is 10, 120 minus 70 is 50, m equals 5. If I plug that in here, b equals 20. We are in calculus, so we must move the quickly. So after I found those values, I'm going to plug them back in. Then they want to know, what was the cost when there were only 2 workers? $30. Simple enough. That should be a review from pre-calc. Moving on, this is a new problem, and it's really, really important that you understand how to solve this problem, because eventually we are going to make it much, much worse. Our last problem for the day. Farmer Jill wants to use 100 meters of fence. So let's just write down things that we know. To enclose a rectangular area that borders a river. So sometimes it's nice to draw a picture, and I cannot find my blue marker, which is sad. It's on the floor. Oh. All right, so we have a river on this side, let's just say, and then we have a rectangular area. Obviously, we do not need fence on the river side. That might not be obvious to you if you have animals who like to swim in a river. But regardless, this is my picture. So I've got the river side here where I don't need a fence, but I do need fencing on this side. So if L is the length of the side parallel to the river and W is the other side, what's the area of the fenced region in terms of L? So we're not actually finding an answer, but they are asking like a numerical answer. They're asking what's the area of this in terms of L. So if they told us what this length would have to be, then perhaps we would be able to find a number for that area. Instead, all I can do is use the information given to try and define the area in terms of L. Right now, if I were to write out the answer, the area is L times W. But I'm trying to get rid of W. So what other piece of information can I use to try and find W in terms of L? Well, they told me that there's 100 meters of fence. So if I add up the sides that need to be fenced, then 100 meters, or the perimeter, should equal W plus L plus W, because these two sides are parallel. Or 100 equals 2W plus L. Now, I'm going to do something weird here. We want this area to be in terms of only L, so I have to get rid of W, which means I need to solve for W here. Then I'm going to plug this in there. So basically what you're doing is you're using the information they've given you to solve this problem by getting rid of, using substitution, W, so that this whole thing is in terms of L. Your book will probably distribute these like that. And that's the area in terms of L. That, my friends, is problem set 5. Woo!